In this tutorial, we'll be looking at the conditions for parallelism and perpendicularity in straight lines. We will be looking at some series of conditions. The first one we'll be looking at is the condition for parallelism, and the second one will be the condition for perpendicularity. For the first one, if two lines are parallel, for example, something like this, then we say that the angle between them is 0. The angle between two lines that are parallel is 0. We now have our alpha to be equal to 0 and tan 0 equals to 0. So going back to the formula for finding the angle between two lines, the formula is defined as tan alpha equals to the absolute value of m2 minus m1 over 1 plus m2 m1, where m2 and m1, they are the slope of these two lines. And now we now have our alpha to be equal to 0. So tan 0 equal to 0. We now have 0 equals to m2 minus m1 over 1 plus m2 m1. Here, if you cross multiply, we are going to have 0 equals to m2 minus m1. And this can be written as m1 equals to m2. And this is the condition. So if two lines are parallel, then their slopes are equal. For two lines to be parallel, I take that again, m1 must be equal to m2. That is, the slope of the first one must be the slope of the second one. Let's look at the second condition, which is the condition for perpendicularity. If two lines are perpendicular, then the angle between them is 90 degrees. Therefore, we have a line AB perpendicular to the line CD. We now have the angle here to be 90 degrees. So going back to the formula for finding the angle between two lines, which is tan alpha equals to m2 minus m1 over 1 plus m2 m1. Here we now have two lines which are perpendicular. So theta equals to 90 degrees. And we have tan 90 degrees to be equal to infinity, which is undefined. So for this fraction m2 minus m1 over 1 plus m2 m1 to be undefined, then the denominator must be equal to 0. For example, if you have x divided by 0, this is undefined. 1 divided by 0, this is undefined. So the same thing here, for m2 minus m1 over 1 plus m2 m1 to be equal to undefined, then 1 plus m2 m1 must be equal to 0. Hope you get that. Then 1 plus m2 m1 must be equal to 0. So we now have here to be m2 m1 equals to -1. And this is the condition for perpendicularity. If two lines are parallel, then the slope of the first one multiplied by the slope of the second one must be equal to -1. This gives us the condition for perpendicularity. We have an example here. Show whether AB is parallel or perpendicular to CD, given the coordinates below. A is 3,1, B is 4,3, C is 4,6, and 5 is 5,8. We have to check whether line AB is parallel or perpendicular to line CD. The first thing we have to do is to look for the slope of line AB. Then we look for the slope of line CD. Then we compare them whether they are parallel or they are perpendicular. To start with, let's look for the gradient or slope of line AB. And in line AB, I'm taking 1 to be the slope of line AB, y2 minus y1 over m2 minus, this is s2, x2 minus x1. We have our y1 to be equal to 3 minus 1. But before we do that, let me write out the coordinates of AB. For coordinate of AB, we have A to be equal to 3,1 and B to be equal to 4,3. So here we have our x1, y1, x2, y2. Going back to the formula, we now have y2 to be 3 minus y1, which is 1, over x2, which is 4, minus x1, which is 3. So this equals to 2 over 1, which is equals to 2. For the second one, which is the gradient of CD, let's represent it by M2. And writing out the coordinates, we have the coordinate of C to be equal to 4, 6, and the coordinate of D, which equals to 5, 8. M2 equals to y2 again minus y1 over x2 minus x1. We now have y2 to be equal to what? This is x1, y1, x2, y2. Y2 is 8 minus 6, which is y1, over x2, which is 5 minus 4. And this is 2 over 1. So we now have 2. Since the gradient of AB equals to the gradient of CD, since we got the same thing here and here, we can say that line AB is parallel to line CD. We should remember that the condition for parallelism is M1 must be equal to M2. Here we now have M1, which equals to 2, and also M2, which equals to 2. Therefore, line AB is parallel to line CD. The second question we have here is this. The question states, if the line AB with coordinates A, -1, M, and B, 2, -3, is perpendicular to the line PQ, P5, 4, and Q, 6, 7, find the value of M. We have to find the value of M from this question. And we are given that line AB is perpendicular to line PQ. Therefore, if line AB is perpendicular to line PQ, and we are assuming that M1 is the gradient of AB, while M2 is the gradient of PQ. Therefore, M1 multiplied by M2 must be equal to -1, which is the condition for perpendicularity. For the first part, let's find M1. M1 equals to y2 minus y1 over x2 minus x1. And from this point, you have y2 to be -3 minus m over x2, which is 2 minus -1. And this equals to -3 minus m over 3. The second part, which is the gradient of line PQ, this is M2 equals to y2 minus y1, just like we have it for M1. And this is x2 minus x1. We now have this. Y2 is 7 minus 4 all over 6 minus 5. And then we have 3 over 1, which equals to 3. I'm going to read the line here. Now, going back to our condition, which is M1 multiplied by M2 must be equal to -1, since these two lines are perpendicular. Our M1 now is -3 minus m over 3 times M2, which is 3, must be equal to -1. This and this will cancel out. We now have -3 minus m equals to -1. And we have m is equal to -3 plus 1. M now equal to -2. And this is how we look for m. We have our m here to be equal to -2. I have some other examples I want us to consider here. This is the first one. It says that find the equation of a straight line which passes through the point 2, 4 and is perpendicular to the line 2x minus 4y plus 3 equals to 0. To analyze this question, we're given a point, which is the point 2, 4, and we're also given a line which is perpendicular to the line we are going to look for the equation of. Let me write out the equation of the line. We have 2x minus 4y plus 3 equals to 0. Note that if two lines are perpendicular, then the gradient of the first and the second one, if you multiply the gradient of the first one and the second line, it must be equal to -1. Take note of this. If two lines are perpendicular, then multiplying the gradient, we must have answer -1. So let's write this equation in the form of the equation of a straight line, which is y equal to mx plus c. And here we have negative 4y equals to negative 2x minus 3. I'm writing this in the form of this. Dividing through by 4, we have over 4 over 4 over 4. So here we have 4y equals to negative 2 dividing 2 by negative 4. Negative 2 over negative 4x minus 3 over negative 4. This will cancel out. Now I have y equal to 1 over 2x minus 3 over negative 4. Considering this equation and this, if you compare these two equations, we have that m equals to 1 over 2. That is, we compare these two equations, the general equation of a straight line and what we derived here. We have y to be equal to y, mx to be equal to 1 over 2x, and c to be equal to negative 3 over negative 4. So we now have our m to be equal to 1 over 2. So to continue, we already got the slope of 1, which is m1. I'm taking that as m1 and m2 to be what we are looking for. So m1 is 1 over 2. That's the slope of the first line that we're given, multiplied by the slope of the line we are looking for. Since the two of them are perpendicular, then the solution must be equal to negative 1. We now have m2 to be equal to minus 2. Therefore, the slope of the line we are looking for is minus 2. Take note, we have gotten two ints here. We have a point and a gradient. Now we are going to use the formula of the form where we have 1 point and 1 gradient, which is m equal to y minus y1 over x minus x1. This was the second equation of a straight line that we looked at. And to apply this formula now, we have our m to be equal to negative 2 equal to y minus y1. y1 is 4 over x minus x1, which is 2. Crossing out and cross multiplication, we have negative 2 to bracket x minus 2 equal to y minus 4. This is negative 2x plus 4 equal to y minus 4. And this is y equal to negative 2x plus 4 plus 4. And this is y equal to negative 2x plus 8. And that is the equation of the line. Y equal to negative 2x plus 8. That is the equation of the line we are looking for. What you have to note here is that we are given the equation of this line which is perpendicular to the line we are looking for. And the slope, if two lines are perpendicular, the slope of the first one multiplied by the slope of the second one must be equal to 0. If it is parallel, if they are parallel, then the slope of the first one must be equal to the slope of the second one. This is the second example. Find the equation of a straight line which passes through the point 2, 4 and is parallel to the line 3x minus 5y plus 2. Just like we have in the previous example, which is perpendicular to the line, here we have parallel to the line. From condition of parallelism, if two lines are parallel, then the gradient of the first one must be the gradient of the second one, which is m1 must be equal to m2. But first, let's look for the slope of the line that we're given. We have 3x minus 5y plus 2 equals to 0. If you write this equation in the form of the general equation of a straight line, which is y equal to mx plus c, we are going to have minus 5y equals to minus 3x minus 2. Dividing through by minus 5, we have y equal to 3 over 5x minus 2 over negative 5. So therefore we have m to be equal to 3 over 5. This is our m1, which equals to 3 over 5. Since the condition is that m1 must be equal to m2, then the equation of the straight line that we're looking for, the slope m2 must also be equal to 3 over 5. Here we have a slope, which is the gradient, and also a point. We can now have the equation of the straight line to be m equal to y minus y1 over x minus x1. As I said before, this is the second form. We have m3 over 5 equal to y minus 4 all over x minus 2. Let's put underline here. Now I have 3 into bracket 5 or x minus 2 equal to 5 in bracket y minus 4. This is 3x minus 6 equal to 5y minus 20. Collecting like terms here, we have 3x minus 5y minus 6 plus 20 equals to 0. And this is 3x minus 5y plus 14 equal to 0. And here we have the equation of the straight line. 3x minus 5y plus 14 equals to 0.